this module, we will examine cavity barriers. These provide effectively the third level of protection in the very highly unlikely event that the automatic fire sprinkler system fails and the fire-rated plasterboard linings are breached during a fire. If this was to occur, cavity barriers prevent the passage of fire or smoke travelling within a cavity from one fire-protected area to another. In this presentation, we will examine the new NCC specification for cavity barriers and the requirements for use, the specific locations that cavity barriers must be used within a building, the types of cavity barriers that can be used, and some details around the installation in floors, walls and roof spaces. The 2016 NCC now contains a new specification, C1.13, Cavity Barriers for Fire-Protected Timber. Cavity barriers are also stipulated to be provided under Clause 3.1d of Specification C1.1, Type A construction, and Clause 4.1e of Specification C1.1, Type B construction. Cavity barriers, as described in the NCC, are barriers placed in concealed spaces formed within or around the perimeter of fire-protected timber building elements that comply with Specification C1.13 to limit the spread of fire, smoke and hot gases to other parts of the building. Specification C1.13 defines exactly where cavity barriers must be located. In mid-rise timber buildings, cavity barriers are required at junctions between fire-resisting floor, ceiling assemblies and fire-resisting internal walls, at junctions between fire-resisting floor, ceiling assemblies and fire-resisting external walls, at junctions between fire-resisting walls and external walls, around the perimeters of door and window openings in fire-resisting construction. Vertical barriers must also be provided in walls up to a maximum distance of 10 metre centres, and horizontal barriers must be provided at each floor level up to a maximum distance of 5 metre centres. The NCC prescribes deemed to satisfy provisions based on a minimum thickness of timber or mineral wool, measured in the direction of heat flow. Specific cavity barrier FRL requirements have been specified to encourage innovative practical solutions, whilst practical timber and mineral fibre-based solutions are specified to provide initial options. For fire-protected timber with an FRL of 90-90-90, the cavity barrier must have an FRL of -45-45. This can be achieved with either timber or mineral wool with a 45mm minimum thickness. For fire-protected timber with an FRL of 120-120-120, the cavity barrier must have an FRL of -60-60. This can be achieved with timber 55mm thick or mineral wool with a 60mm minimum thickness. There are a range of proprietary cavity barrier materials available. These, though, are required to have been tested to meet the NCC compliance requirements, and manufacturers should be asked to provide specific test certificates to demonstrate compliance. Horizontal cavity barriers are required at the junctions between fire-protected timber floor assemblies and fire-protected timber walls in frame construction. Looking in detail at this section of a fire-protected timber wall floor junction, with beams running parallel to the walls for a Class 2 building, you can see here the placement of a mineral fibre cavity barrier between the floor beams, and also the use of solid timber cavity barriers closing off the wall systems. This slide provides a similar detail. However, in this scenario, the floor joists are running perpendicular to the fire-protected timber wall. But again, it can be seen that both mineral fibre cavity barriers are used between the floor systems and timber blocking is used as a cavity barrier in the floor ceiling cavity and in the wall cavities. At an external wall and floor junction, a similar detail is used, with timber and mineral fibre cavity barriers. But in this external location, an impervious membrane is also needed to control moisture issues. The NCC also stipulates that vertical cavity barriers are required at the intersections of any fire-rated walls, and also at least 10 metre maximum horizontal centres if a single fire-rated wall is longer than this. These two plan view details show two options for installing cavity barriers, where a double-stud fire-protected timber internal wall intersects with an external brick veneer wall. The first option utilises a single appropriately wide cavity barrier, while the second option illustrates the use of two smaller individual cavity barriers, one for each wall. This plan view detail shows the intersection of a double-stud fire-protected timber internal wall with a single wall running at right angles. A single wide cavity barrier has been used in this instance. It is important to note in this detail the use of two timber studs that provide compressive support to the cavity barrier. In meeting the requirement for cavity barriers to be installed at least 10 metre maximum horizontal centres, this plan view detail illustrates this intermediate vertical cavity barrier in a double stud fire protected timber wall. Note that timber studs of minimum 45mm thickness also need to be provided to block the cavity and provide support to the mineral fibre cavity barrier as shown. Special attention also needs to be given to the design of roof spaces to address the risk of uncontrolled fire spread throughout the roof space. Generally, there are two approaches that can be adopted. Option 1, shown here in section, shows the fire-grade plasterboard on the walls extending above the ceiling line and up into the roof space for the full height of the separating walls. This has the advantage that these ceilings to the top floor do not need to be fire resisting because the wall extension can provide the necessary fire and sound separation. Mineral fibre cavity barriers need to be installed though, at the ceiling level as shown and also importantly at the ridge of the external roof level. In option 2, shown here in section, a fire-rated ceiling has been used in the upper level sole occupancy units. In this case, the roof spaces would need to be divided by cavity barriers above each of the SOU bounding walls. Where the roof void is relatively deep, it may be impractical to apply the deemed to satisfy solutions of solid timber or mineral fibre, and a plasterboard partition achieving the required FRL of 45 minutes for a cavity barrier in a Class 2 building may provide a more practical solution as shown here. Again, mineral fibre cavity barriers need to be installed at the ceiling level as shown and also at the ridge of the external roof level. Cavity barriers are also required to be fitted around the perimeter of openings, such as unprotected windows in external walls, to prevent premature entry into the fire-protected timber cavities at these positions. The section view through a window opening shown here illustrates how cavity barriers need to be installed around the full perimeter of the window. Proper installation is critical in relation to the performance of cavity barriers in the event of a fire. Practical installation issues that have been observed and reported in the UK that need to be highlighted include discontinuities between sections of horizontal cavity barriers, gaps between horizontal and vertical cavity barriers, removal of horizontal cavity barriers during bricklaying operations, debris left in the cavity on top of the horizontal cavity barriers, gaps between sections of vertical cavity barriers, gaps between vertical barriers and brickwork, meaning a lack of compression in the cavity barrier, bricks laid too close to the timber frame to accommodate cavity barriers, and solid timber which cannot deal with dimensional variations and inconsistencies in cavity widths. Cavity barriers must be installed correctly in accordance with manufacturer's instructions and not damaged, removed or interfered with during the period between installation and completion of the external rain screen facade. The choice of the type of cavity barrier to be employed in any specific scenario should be an integral part of a building's design, which should consider the likely risks and consequences associated with a fire event. Certain products are more likely to continue to provide their regulatory function even where gaps and discontinuities are present, and a number of potential options are available to designers and specifiers. In summary, cavity barriers must be provided in all locations as per the requirements of specification C1.13. The NCC prescribes DTS provisions based on minimum thicknesses of timber or mineral wool in the direction of heat flow. A range of proprietary cavity barrier products are available. However, it is important that manufacturers provide specific test certificates to demonstrate compliance. And proper installation is critical in relation to the performance of cavity barriers in the event of a fire. So cavity barriers must be installed correctly in accordance with manufacturer's instructions. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.